When we are adding decimals, we need to make sure that we line up our place values perfectly. The very important thing is that our decimal points line up and for us to put in any necessary placeholders. And then just to remember to put in our plus sign. And then we just work from right to left. We say 6 plus 0 is 6, 3 plus 5 is 8, 0 plus 8 is 8, and we bring down our decimal point, and 9 plus 0 is 9. So our answer to 9.036 plus 0.85 is equal to 9.886. Right, if we have a look at another example, let's say 38 plus 9.4. What we need to do here is, because we are working with a whole number, we need to remember where our decimal point is in any whole number. So we've got 38.0, because remember that doesn't change the value of our 38, it just helps us when we are working out. And then we remember that our 9 here is a unit, so we put it under the 8, and then we've got 4 tenths, and then we put in a placeholder there because we have got 0 tenths. And then we add these together, and we have 0 plus 4 is 4, 8 plus 9 is 17, carry our 1, 3 plus 1 is 4, plus 0 is 4. So 38 plus 9.4 is equal to 47.4. Right, if we have a look at 90.372 plus 35.93. Again, what we need to do is line up our place values perfectly and put in a placeholder there because we have 0 thousandths. So then we remember to add 2 plus 0 is 2, 7 plus 3 is 10, carry our 1, 3 plus 1 is 4, 4 plus 9 is 13, we bring down our decimal point, 1 plus 5 is 6, and 9 plus 3 is 12. So 90.372 plus 35.93 is equal to 126.302. When we are subtracting with decimals, the same sort of rule applies as when we were plussing with our decimals. So we need to put in our placeholders, we need to line up our decimal points, and we need to make sure that our place values are all lined up. So 100 is a whole number, but we're minusing from 100 a number that has 1, 2, 3 decimal places. So 100.000 gives us our placeholders, and then we put in our decimal point, and we've got 3 units, and then 205. And then we put in our placeholders there, and we remember that we are minusing. Right, so 0 minus 5 we cannot do. So we would usually go to the place value to the left, which is a 0, and we cannot actually borrow from our 0. So we go all the way to our 1, and we borrow from our 1, that becomes a 0. We carry our 1 over, borrow from our 10, which becomes 9, carry our 1 over, borrow from our 10, becomes 9, and so on. So now we have 10 minus 5, which is equal to 5. 9 minus 0 is equal to 9. 9 minus 2 is equal to 7. Bring down our decimal point. 9 minus 3 is equal to 6, and 9 minus 0 is equal to 0. And over here we've got 0 minus 0, which is just equal to 0. So 100 minus 3.205 will give us an answer of 96.795. Right, let's have a look at another example. 8.229 minus 0.4. Right, so 8.229, we are minusing 0.4 from that number. So we put in our placeholders and we minus. 9 minus 0 is 9. 2 minus 0 is 2. 2 minus 4 we cannot do, so we borrow from our 8. That becomes a 7. Carry our 1 over. 12 minus 4 is equal to 8. Bring down our decimal point. 7 minus 0 is equal to 7. So 8.229 minus 0.4 will give us an answer of 7.829. Right, let's look at 5.9 minus 2.001. If we have got we've got our units and a tenth, but we do not have a hundredth or a thousandth. So we have got 2 with tenths, hundredths, and thousandths, which is why we put in these placeholders. And then we're minusing. 0 minus 1 we cannot do, so we try and borrow from our next place value, which we cannot because it's also 0. We borrow from our 9, then that becomes an 8. Carry our 1 over, that becomes a 9. Carry our 1 over, so 10 minus 1 is 9. 9 minus 0 is 9. 8 minus 0 is 8. Bring down our decimal point. 5 minus 2 is equal to 3. So 5.9 minus 2.001 is equal to 3.899. When we are multiplying decimals by 10, 100, 1,000, or a million, or whatever it might be, we need to try and understand that the number is getting 10 times bigger, or if you are multiplying by 100, it will be getting 100 times bigger, and that is because we are multiplying. So when we divide, our number gets smaller. When we are multiplying, our number gets bigger. And that is when we are multiplying by whole numbers. So 30.08. At the moment, we have 30.08. In terms of our place values, we've got 3 tens, 0 units. There's our decimal point. Then we've got our tenths, and we've got our hundredths. So when we are multiplying by 10, each of these place values are going to become one place value bigger. So the 3 tens is going to become 3 hundreds. Okay, and the 0 units is going to become 0 tens. And the 0 tenths is going to become 0 units. The 8 hundredths is going to become 8 tenths. And then there are an infinite number of zeros afterwards, which don't change the value of the number at all. So you can put 0 hundredths there. That would have been our thousandths, getting 10 times bigger to become 0 hundredths. But that doesn't change the value of our number. So when we are multiplying 30.08 by 10, we will end up with an answer of 300.8. So if we have a look at 30.08, and instead of doing all of this working out just in a simple test that we are working through, What we can do is, if we understand that each of these digits is actually moving to the left because the place values is getting bigger when we are multiplying, what we can do is we can, even though our decimal point never actually moves, what we can do is pretend that our decimal point is moving to the right by one place value, and that will kind of show us that, in a sense, our numbers, our digits are moving to the left. So if we move our decimal point one place to the right, that shows us the same answer, 300.8. Right, so if we take this number, 30.08, and we multiply it by 100, what we will do is we take our decimal point and we move it 2 places to the right. And the reason we move it 2 places to the right is because 100 has 2 zeros. So with 10, we only moved it 1 place to the right because 10 only has 1 zero. But when we are multiplying by 100, because it has 2 zeros, we move our decimal point 2 places to the right, but obviously bearing in mind that it isn't actually the decimal point that's moving to the right, it's actually our numbers. So it's actually 3008.0. So that is our answer. And the reason that we have that answer is because at the moment, so there was our decimal point, our 3 tens become 100 times bigger, so our 3 tens now becomes 3 thousands. It moves 2 place values to the left. So from tens, then hundreds, then it moved to our thousandths column. And then our 0 there, which was in the units column, is now in the hundredths column. And our 8, which was in the hundredths column, is now in the units column because it has become 100 times bigger. Right, so let's have a look at some other examples. If I've got 9.837 and I would like to multiply that number by 10, all I need to do is take your decimal point 1 place to the right, and you end up with an answer of 98.37. Right, if we have a look at another example, 0.037, I would like to multiply this number by 1000. I have to move my decimal place 1, 2, 3 places to the right because my number is getting 1000 times bigger and 1000 has 3 zeros. I move my decimal point 1, 2, 3 places to the right, so I end up with 37. Okay, and now if I have 0.9 and I would like to multiply this number by 10,000, what I need to do is put in some placeholders there because that doesn't change the value of my number at all. So if I put in these 3 placeholders, that makes it slightly easier for me. So I go from my decimal point 1, 2, 3, 4 places to the right because 10,000 has 4 zeros, and I end up with an answer of 9,000. When we are dividing by 10, 100, 1,000, or 1,000, 1 million, or whatever it might be, we again just need to understand what happens to our number when we are dividing. So we've got 13.8, which has 110, it has 3 units, and it has 8 tenths. So when we are dividing by 10, which has 1 0, each of these digits is going to move 1 place value to the right. So our 110 is going to become 1 units, and our decimal point stays in exactly the same position. our 3 units is going to become 3 tenths, and our 8 tenths is going to become 8 hundredths. Right, because there were 0 hundredths there in the first place, so that 0 can go into the thousandths column, but that doesn't change the value. So 13.8 divided by 10 gives us an answer of 1.38. Now, just as another explanation, if we consider our 110, so 10 divided by 10, which is what we were doing, gives us an answer of 1. 3 units divided by 10 gives us 3 tenths. That's why our 3 is now in our tenths column. And 8 tenths divided by 10 gives us 8 hundredths. So that makes sense. And as we can see, 13.8 divided by 10, if we were to consider moving this decimal point one place to the left, we would end up with the same answer, 1.38. So that is how we can work our divisions out just on paper instead of doing all this working out. So to show you're working out in a test, you can move your decimal place one place to the left when you're dividing by 10, as long as you understand that it's actually the digits that are moving one place value to the right. So let's have a look at 9.32 divided by 100. So we write 9.32 and we put in some placeholders, and because we are dividing by 100, we're going to move our decimal point 2 places to the left, even though we know that it's our numbers that are moving to the right by 2 place values. So we end up with an answer of 0.0932. Right, if we have got 392 divided by 1000, this is now a whole number. So we need to remember in any whole number, the decimal point is going to be at the end, and then we can put 0.0 to help us with our working out. And because we are dividing by 1000 with 3 zeros, we bring in 1, 2, 3 decimal places to the left. We can put in our placeholder because that's where our new decimal point is going to be, and our answer is 0.392. (973) divided by 10. So we write out 973.0 and we divide that by 10. We bring in 1 decimal place and our answer is 97.3. When we are dividing by 10,000, we need to bring in 1, 2, 3, 4 decimal places. So we go from our decimal point, and because we are moving to the left, because our numbers are moving to the right, or our digits are moving to the right, we move in 1, 2, 3, 4 places. So we end up with an answer of 1.39734. When we are multiplying decimals by multiples of 10, 100, or 1,000, or 10,000, or whatever it might be, what I suggest you do is you work out 0.8 times, and then you break this 20 up into 2 times 10, or we can write it as 0.8 times 10 times 2, because this 2 times 10 or 10 times 2 is equal to our 20. So it might just be easier to work out 0.8 multiplied by 10, which will give us an answer of 80 because of 8, I beg your pardon, because we move our decimal point one place to the right. So we end up with 8 multiplied by 2, which gives us an answer of 16. So let's have a look at another example. If we have got 30 times by 9.3, what we can work out here is 3 times 10 times 9.3. So we work out our 10 times 9.3, which should give us an answer. We multiply by 10, so we move our decimal point one place to the right, so we end up with 93. And then 3 times 93 we can do on the side, and we end up with 3 times 3 is 9, 3 times 9 is 27. So 30 times 9.3 gives us an answer of 279. Right, so if I have got 0.5 multiplied by 600, what I can do is break my 600 up into 100 times 6, so 0.5 times 100 times 6, and I end up with 0.5 multiplied by 100, so I go 2 places to my right, so that gives me 50. So 0.5 times 100 is 50, times by 6, and that will be 5 times 6 is 30, times by another 10 is 300. Right, let's look at another example. 1.2 times 4,000. I can say 1.2 times 1,000 times 4, because 4,000 is equal to 1,000 times 4. And then I can say 1.2 times 1,000, so 1.2, and because it's 1,000, I need to take my decimal place 3 places to the right. So let me put in some placeholders. 1, 2, 3. So I end up with 1,200 multiplied by 4. What I can do then is say 12, because 1,200 is 12 times 100, I can say 12 times 4 is equal to 48, and then I can multiply 48 by 100 to get an answer of 4,800. When we are dividing decimals by multiples of 10, 100, and 1,000, what we would like to do is first divide our 1.5 by 10, because 50 is a multiple of 10, so 50 is equal to 5 times 10. So we would like to divide 1.5 by 10 first. So 1.5 divided by 10, we're moving to the left because we are dividing. So our decimal point moves one place to the left. So we end up with 0.15, and then we are just dividing by 5. And what we can do here is we can put our 0.15 inside our division house, and then we are dividing it by 5, which is much easier than having 50 outside our division house. So 5 into 0 doesn't go, so you put your 0 above the 0, and then you bring up your decimal point exactly in line, and then 5 into 1 doesn't go, so we put our 0, and then we have 1 left over. 5 into 15 fits 3 times. So 1.5 divided by 50 gives us an answer of 0.03. When we are working with 4.5 divided by 900, we first want to divide our 4.5 by 100, and then we'll divide that answer by 9. So 4.5 divided by 100, we go from our decimal point 2 places back, we put in our placeholders, and we end up with 0.045 divided by 9. So we can put our 0.045 inside our division house, and then we have our 9. 9 into 0 goes 0 times, bring up our decimal point. 9 into 0, 0 times. 9 into 4, 0 times. 9 into 45, 5 times. So 4.5 divided by 900 gives us an answer of 0.005. 0.42 divided by 70, we would first like to divide 0.42 by 10. So we bring in one decimal place, which is 0.042, and then we just divide that by 7 because we've dealt with our tens. So 0.042 we put inside our house, our division house, and we bring our 7 outside. 7 into 0 goes 0 times, bring up our decimal point. 7 into 0, 0 times. 7 into 4, 0 times. 7 into 42, 6 times. So we end up with an answer of 0.006. So 0.42 divided by 70 gives us an answer of 0.006. When we are multiplying decimals with decimals or decimals with whole numbers, we need to firstly understand that decimals can be converted into equivalent fractions, and let's first work with that and then we'll work with a slightly shorter method. So 0.3 is equal to 3/10 because we've got one decimal place, so our fraction is going to be over 10, and then we just have a look at our number without the decimal point, and that is 3. So we've got 3 over 10, multiply that by 4 over 1, and this is the only time that I don't want you to cross cancel, because we were asked this question in the decimal format, we will have to give our answer in the decimal format as well. So 0.3 multiplied by 4 is equal to 3/10 multiplied by 4 over 1. So all I would like you to do now is multiply your numerators. So 3 by 4 is 12. And 10 by 1 is our denominator's answer is 10. So the reason I didn't want you to cross cancel is because I would like you to keep either 10, 100 or 1,000 as your denominator so that it is much easier to bring our answer back into the decimal format. So 12 over 10 is equal to 12 divided by 10, because remember, a fraction is exactly the same as a division. It's just our numerator divided by our denominator. So 12 divided by 10 is equal to 12.0 divided by 10. So because we're dividing by 10, we just bring in one decimal point. We move our decimal point one place to the left, and we end up with an answer of 1.2. Right, let's have a look at 0.3 times 4, this exact same question there, but let's look at a different way of working this out. So this first method that we used is a very good way to understand what we are actually doing and everything that happens behind the scenes. But once you understand that, what we can do is we can count how many decimal places there are altogether. So here we have got one decimal place. because we don't need to count that 0.0 because we're not going to be using 40, we are going to be using 4. So we've only got one decimal point here. So you put a big star and a 1 to say we've got one decimal place, right? And then what we do is we ignore the decimals. So we pretend as if this 0.3 is just 0.3 or just 3, because that 0 doesn't change the value, and then this 4 will just stay the same. We work that out to be 12. We put in a decimal place so that we can bring in our one decimal place again, and our answer is 1.2 as well. So let's have a look at a different example. If we have got 3.4 multiplied by 8.3, what we need to do here is we need to work out 34 over 10 because we've got one decimal place, and then 8.3 is going to be 83 over 10 because it's got one decimal place. We then say 34 times 83, which we need to do on the side. So 34, 83. Remember to put in your 0 when we are multiplying with our tens. And then we've got 4 by 3 is 12, carry our 1. 3 by 3 is 9, plus 1 is 10. Let's cross that out. 8 times 4 is equal to 32. 8 times 3 is 24, plus 3 is 27. 2, then we're plussing these. 2 plus 0 is 2. 0 plus 2 is 2. 1 plus 7 is 8, and then we've got 2. So we end up with an answer of 2822 as our numerator, and 10 times 10 is equal to 100. So this is equal to 2822 divided by 100, because a fraction is the same as a division. And what we do then is we remember that in any whole number, the decimal point is at the end. And because we are dividing by 100, we bring in 2 decimal places to the left, and our answer is 28.22. Right. Now, if we were to have a look at this using the slightly shorter method, like what we did here, we would say 3.4 times by 8.3, and we would count how many decimal places there are all together. So in this entire question, how many digits are there after the decimal points? That's basically what we're asking. So we've got one decimal place in this number, 3.4, and one decimal place in 8.3. So we've got one there, one there. We add those together. We put a big star to say we've got 2 decimal places all together that we need to bring in at the end. And then we work out 34 times by 83, because then we ignore our decimal points because we've already made note of that. And that is equal to 2822 as we worked out there. And then all we need to do is bring in our 2 decimal places. So that's 0.0, bring in 2 decimal places, and our answer is equal to 28.22. Let's have a look at a few more examples when we are multiplying decimals by decimals. So 0.08 squared, we need to rewrite as 0.08 times 0.08. So what we can work out here, firstly, we can work it out to be 8 over 2 decimal places, so it's going to be over 100. And we can multiply that by 8 over 100 because they are exactly the same number. And then we say 8 times 8 is equal to 64, and 100 times 100 is equal to 10,000, and 64 over 10,000 is equal to 64 divided by 10,000. So because 10,000 has 1, 2, 3, 4 zeros. I work out 64.0, put in some placeholders, and I need to bring in 1, 2, 3, 4 decimal places. So my answer ends up being 0.0064. So 0.8 squared is equal to 0.0064. And let's have a look at the shorter method. If we would like to figure out how many decimal places there are altogether in this question, we've got 1, 2 decimal places there and 1, 2 decimal places there. So we add those together and we put a big star with a 4 to indicate that we've got 4 decimal places altogether. And then we ignore these decimal places and we say, well, that's just 8 times 8, which is equal to 64. And then I need to remember to bring in my 4 decimal places. So I've got 64.0, put in some placeholders, bring in 1, 2, 3, 4 decimal places, and I have 0.0064, which is equivalent to that one. So you can use whichever method works best for you. This method, converting them into fractions first, is definitely better for when you are still getting used to multiplying with decimals. So let's have a look at another example. 0.6 squared, or just 0.6 squared. What we need to work out is what 0.6 will be as a fraction. So 6 over 10 by 6 over 10, because we've only got one decimal point. So 6 times 6 is 36. 36 over 100, because 10 times 10 is 100. That'll give us an answer of 0.36, because we're dividing by 100, we bring in 1, 2 decimal places. Right, so if we would like to look at the quicker method, we've got 0.6 times 0.6, or let's write it out here, 0.6 times 0.6. So we've got 1 decimal place there, 1 decimal place there. Altogether, we've got 2 decimal places. So we need to bring in 2 decimal places at the end. We say, then we ignore our decimal points. 6 times 6 is equal to 36. And then I bring in my 2 decimal places, 1, 2, and I still get an answer of 0.36. When we are dividing with decimals, we need to make sure that we convert our decimals into fractions. So with this example, because we are dividing a decimal by a whole number, what we can actually do is just put our decimal inside our division house and put our 12 outside the division house and just do a normal division. So 12 into 1 doesn't go. We bring up our decimal point, carry our 1 over. 12 into 14 goes once, remainder 2. 12 into 24 goes twice. So we end up with an answer of 0.12. So this is when we are dividing a decimal by a whole number, because we don't mind having that whole number outside our division house. If, however, we are dividing 0.25 by 0.5, what we can do is we can multiply both these numbers by 10 in order to get a whole number here. So if we remember that 0.25 divided by 5 is equal to 0.25 over 0.5, if we multiply our denominator by 10, we have to multiply our numerator by 10 as well. So we get an answer of 5 in our denominator and 2.5 as our numerator. So we multiplied our 0.25 by 10 to get 2.5, and then we multiplied our 0.5 by 5 to get an answer of 5. So we ended up with 2.5 divided by 5, which is exactly the same thing. It's just working with smaller numbers or with easier numbers. So when we are working with 2.5 divided by 5, we work exactly in exactly the same way as if it wasn't a decimal inside our division house. So we just bring up our decimal point. 5 into 2 doesn't go. Carry our 2 over. 5 into 25 fits 5 times. So 0.25 divided by 0.5 is equal to 0.5. Right, if I would like to work out what 8.4 divided by 1.2 is equal to, I now have to convert. I don't have to, I can still multiply them both by 10 to get 84 divided by 12, which we know is equal to 7. But what we are going to do is we are going to convert both of these numbers into fractions. So 8.4 is equal to 84 over 10, and 1.2 is equal to 12 over 10. And when we are dividing with fractions, what we need to do is keep our first fraction the same, and we multiply. So we flip our division into a multiplication, and we flip the second fraction as well. We flip it over, so it becomes the opposite. So 12 over 10 now becomes 10 over 12, and then we can cross cancel, and then we end up with 84 and 12, which I can cross cancel down. 84 and 12 into 84 goes 7 times. 12 into 12 goes once. So we end up with an answer of 7, as we did there. .6 divided by 1.2. We are going to have a look at this in terms of our fractions. So we are going to convert these both into fractions. So 0.6 is equal to 6 over 10. And we are going to divide that by 1.2, which is equal to 12 over 10. That is because they both have one decimal place. That's why they're both over 10. And what we need to do now is keep our first fraction the same, convert our division into a multiplication, and flip our second fraction. So we end up with, we cross cancel there, and we end up with 6 into itself once, 6 into 12 twice. So we end up with a half, but we know that we have to convert our answer back into a decimal because we were asked in the decimal format. So a half is equal to 0.5. So 0.6 divided by 1.2 is equal to 0.5. Right, so if we have 0.35 divided by 0.007, again we would convert 0.35 into 35 over 100, which is its fraction equivalent, and we divide by 7 over 1000. So 7 over 1000, we've got 1, 2, 3 decimal places, that's why it's over 1000, and then we end up with 35 over 100 multiplied by 1000 over 7. And 35, well, we can first divide 100 by 100 to get 1, divide 1000 by 100 to get 10, and then divide 35 by 7 to give us 5, and 7 by itself gives us 1. So we end up with 5 times 10, which is 50, and that's over 1, so we just get an answer of 50. So 0.35 divided by 0.007 gives us an answer of 50. 3.6 divided by 0.6. 36 over 10 divided by 6 over 10, and we can say 36 over 10 multiplied by 10 over 6. We can cross cancel, 36 into 6, or 6 into 36 6 times, and 6 into itself once. So we end up with 6 times 1 is 6 over 1, which is equal to 6. So 3.6 divided by 0.6 will give us an answer of 6.